In this video we're going to talk a bit more about defining functions in Python. So as a basic example, let's so here we're going to define a function called double x, and the return value is just x times 2. Okay. So note the syntax here. We have the word def for defining function, and the name of the function, then brackets, then the arguments, always a colon on the end, and then on the next line you start doing any work to define the function. At the end, the value that you want to return as the value of the function, you have to have a return statement. Okay. And so now we can do double of 1, 1, 1, 1 is 2, 2, 2, 2, and so on. It's worth noting that x star 2 works for a bunch of other things as well as just for numbers. If we double a string like A, B, C, D, then it'll just give us 2 copies of the string joined onto each other. Same kind of thing works for lists. You start with the list 1, 2, 3, 4, then you get 1, 2, 3, 4, 1, 2, 3, 4. Yeah. And you can double a bunch of things, but one thing you can't do is just double a function, right? You try to apply a double to itself, that doesn't work. Okay. Similarly, we can define a squaring function. Remember, x star star 2 is the thing for squaring something. So we can do a square of square of a number. Let's also try square of a complex number. So we do 1 plus I. Mathematicians would normally call the square root minus 1i, but in Python, as in many kind of engineering things, for example, it's typically called j. And technical reasons, you can't just write j, you have to write 1j. So you've got 1 plus j, and we're going to take the square of that, and you get 2j. Yeah, that's a little exercise that you can do by hand if you want. But here this basically only works with numbers. If we try and square a string, we get an error message. And you should get used to kind of reading these error messages and trying to understand what they're telling you. So it says type error, and it says you've got this little line of arrow here which is pointing to the line where something's gone wrong, and it says unsupported operand types for double style. Okay, so str and int. So what that means is the x is a string, and the 2 is an int, and it doesn't know how to do raising a string to an integer power. Okay, so that's what this error message means. Okay, so now I'll have something just a tiny bit more complicated. At least initially not any more complicated. Let's emphasize a string by adding a exclamation mark on the end. Yeah, so notice here, I made a mistake. I mistyped this. I left out the E on the end, and I'll get this kind of little wiggly line here to indicate that something's wrong. And then if I hover over it, I get a slightly more specific thing that emphasis is not defined. So I put the E there, then it works out. Okay. So now emphasize high, and it gives me with an exclamation mark. But let's try and do something a tiny bit more, where maybe we add more than one exclamation mark, and maybe we add some question marks as well. So okay, so okay, so so here I add any number of exclamation marks and any number of question marks. So I try and run the function again. Oh, but it's not working. What have I broken? Well, let's have a look again at the error message. It says emphasize missing 2 required positional arguments, excitement and doubt. Now, so I have to actually say how many exclamation marks and question marks I want. So let's maybe have 3 exclamation marks and 2 question marks, like so. But it would kind of be better if I didn't have to do that, if I could just default to having just 1 exclamation mark if I didn't specify any more. So but we can do that. We can do excitement equals 1, doubt equals 0. Yeah, so you can do this to give default values for these arguments. Okay, so now if I do emphasize with no arguments, then we just get the default values. If I do just with just a 5, okay, so then I've supplied 5 as the value of excitement, and I haven't supplied the value of doubt, so the value of doubt defaults to 0 as it is there. So I just get the exclamation marks. I do 5 and 2, then I get the 5 exclamation marks and 2. And the other thing is, these are so-called keyword arguments. They've got names, and that means that I can give them in a different order if I want to. So I could just say doubt equals 7, and then so now I've got a single question mark because excitement is defaulting to 1, and then the doubt is 7. Maybe I don't want any excitement, so I put excitement equals 0 there. And notice that because I've actually specified the names of the arguments specifically, I'm allowed to give them in the opposite order. Okay, so it said in the definition I had excitement first and doubt afterwards, but now because I've actually given the names, I can give them backwards. So that's an example of default arguments. But it's best actually if I add documentation to my functions to explain what they do. Okay, so I'm going to have a string here with triple quotation marks. And so this is called a docstring. Most functions, any function that does anything remotely sophisticated, should have a docstring to explain what it does. So and it goes directly after the name of the declaration of the function at the top. A multi-line string delineated with triple quotation marks. Okay, so So that's a doc string, which that's a fairly typical doc string to explain what the parameters of the function are and what it does. Okay, well now we'll do maybe a slightly more mathematical example. We'll do Fibonacci numbers. So so what's this? This is going to give us the list of the first n Fibonacci numbers. Okay, so well, maybe we should remind ourselves what the Fibonacci numbers are. So let's put in a markdown cell here. Fibonacci numbers are defined by the following rules. Okay, so the Fibonacci number is defined by this. So we start with f0 is 1 and f1 is also equal to 1, and then fn is fn minus 1 plus fn plus 2 later on. Okay, maybe we can shall we just add some examples to this comment here. Okay, so this is f2. Well, f2, we use this rule here. f2 is the sum of the previous two values, so it's f0 plus f1. Both of those are equal to 1, so you get 1 plus 1, which is 2. And then for f3, that's the sum of the previous two things. So you've got the 1 here and this 2 that we just had, so that's giving you 3. f4 is the sum of this 2 and this 3, giving you 5, and so on. So we want to get the whole list, so so we start by recording the first two values like so. And then after that we we have to take the sum of the last two things. So we've got fib minus 1, remember that always means the last element in the list, so that's the last thing, and then fib minus 2 is the one before the last thing, so we do fib minus 1 plus fib minus 2, that's the sum of the last two Fibonacci numbers that we've already calculated, and so then we want to add that on to the end of our list. Okay, so we take the sum of the last two things that we've seen already, and we append that to the end of the list. Okay, so now we're building up this whole list, and we return the list that we've built. Okay, so then we can do so here's our list of the first 10 things. So as we said up here, it starts kind of 1, 1, 2, 3, 5. And then after that, 8 is 3 plus 5, 13 is 5 plus 8, 21 is 8 plus 13, and so on. we try and do 10.5 or something, we so something's in there wrong here. We're supposed to do, it says range 2, n, but n is equal to 10.5 here, and so range 2 to 10.5 is not defined. So we get an error message. It'd be better to have a kind of maybe a more comprehensible error message. So let's just change this to generate our own error message directly. So so we want to check whether n is sensible. So we use this isInstance first. Okay, so we want n to be an integer. So to test that, we do isInstance n int. Is n an instance of the type integer, which that's what we're looking for. But also, if it's an integer, integers can be negative, so it doesn't really make sense to do Fibonacci -7 or something. In fact, it doesn't even really, this method that we've got here, it doesn't work properly if n is less than 2. So if it's not greater than or equal to 2 and an integer, then we want to fail. And so we could sort of print an error message and stop or something, but it's kind of better to use the standard Python error handling system. So to do that, we're going to raise an error. And it's going to raise a value error. So various different kinds of error, but when you've got a function that's been supplied with a value that it can't actually process, then the appropriate thing usually is to raise a value error. So we'll say so so if we get an inappropriate n, then we're going to raise a value like that, raise a value error like that, and otherwise we carry on and do the right thing. So now so now instead of just getting a very generic error message, we get a slightly more specific value error. N must be an integer greater than or equal to 2. And if we do Fibonacci 1, then again we're going to get the same sort of thing here. That's slightly unsatisfactory because there's not really any problem with evaluating Fibonacci 1. It's just that the logic we did here, starting with a list that already has length 2, doesn't work quite correctly. So instead of, let's actually put in some extra logic to make that work correctly. So now here we're just saying that n is less than or equal to 1, which means 0 or 1, then we're going to return 1. Okay. And now we've changed this check here, so it's only checking that n should be greater than or equal to 0. Okay, so now we fixed that. Fibonacci 1 works correctly. Fibonacci 0 also works correctly. Fibonacci -1, then we get a value error again. So that's some basic examples of defining functions, and we'll leave it there for the minute.